Hello everyone, this is Niharika from Sri Venkateswara College of Engineering, and I am here with a new subject, Digital Design and Computer Organization. Here is my topic, Evolution of Digital IC Technology and its naming pattern. The progression of the evolution of integrated circuits started with the evolution of vacuum tubes invented in 1897 by John Ambrose. Transistors further replaced vacuum tubes in the year 1947, created by William Shockley, which brought a new boom to the electronic industry. Let us study what is an integrated circuit. IC stands for integrated circuits. It is a miniaturized assembly of electronic components such as transistors, resistors, and capacitors that are fabricated on a semiconductor material. The components are interconnected to perform a specific function, and the entire assembly is encapsulated in a single package. Integrated circuits come in various types, including analog IC that handle continuous signals and digital ICs that process the discrete signal, that is binary code. ICs have revolutionized electronics by enabling the creation of compact, efficient, and powerful electronic devices. Let us study the complete evolution history of integrated circuits. Transistors from small scale integrated circuits to ultra large scale integrated circuits. Let us study from small scale integrated circuits to ultra large scale integrated circuits. Small scale integrated circuit is a technology that was first used to describe the fabrication of 10 to 100 transistors on a single chip between 1961 to 1965. This stood helpful for the manufacture of flip-flop and logical gates. Second one is medium scale integrated circuits. Between 1966 and 1970, the word was a draft from small scale integrated towards a medium scale integrated integration, wherein the experts could fabricate between 100 to 1000 transistors on a single chip. The medium scale integration proved helpful for the construction of multiplexers, counters, and decoders. Let us move on to large scale integration. With the advancement of technology later, in between 1971 and 1979, thousands to 20,000 transistors could be fabricated over a single chip, giving birth to the concept of LSI. This technology proved handy in manufacturing RAM and ROM and microprocessors. Let us move on for a fourth evaluated integration, that is large scale integration. As the name suggests, this technology allowed a huge number of transistor fabrications on a single chip, about 20,000 to 50,000. VLSI made developing RISC 16 and 32-bit microprocessors and DSP-EC. This practiced the technology between the years 1980 to 1984. Let us move on to the ultra large scale integration. Following in 1985, there was a considerable technical breakthrough which allowed the fabrication of more than 50,000 transistors to billions of transistors on a single chip. This technology then found this usage in the making of 64-bit processors. Let us move on to types of integrated circuits. Digital integrated circuits, analog integrated circuits, mixed signal integrated circuits, three-dimensional integrated circuits. Let us study from digital integrated circuits. They are categorized as in logic IC, such as microprocessors and microcontrollers, memory chips such as MOS memory and floating gate memory, interface ICs, level shifters, serializer, deserializer, etc. Power management ICs and programmable devices. Analog ICs are categorized as linear integrated circuits and RF circuits, that is radio frequency circuits. Mixed signal integrated circuits are categorized as data acquisition ICs, including AD converter, DA converter, digital potentiometers, clock or timing ICs, switched capacitor circuits, and RF CMOS circuits. Three-dimensional integrated circuits are categorized into through silicon viva ICs and copper-copper connection ICs. Let us move on to an evaluation of naming IC patterns. The naming of IC patterns has evolved alongside the advancement of semiconductors technology. In everyday, ICs were relatively simple and naming conversions were straightforward, often reflecting the function of purpose of the circuit. As technology progressed and complexity of ICs increased, more systematic approaches were needed. One common method is the use of technology nodes, indicating the manufacturing processes feature size. For example, you might hear terms like 90 nanometer technology and 7 nanometer technology, where the number of representations than minimum feature size is nanometer. Smaller feature size generally allows for more transistors on a circuit, improving performance and efficiency. Additionally, naming conventions may involve generational labels or series names assigned by semiconductor manufacturers to distinguish between iterations of their products. These labels often highlight improvements in performance, power efficiency, or other key features. As semiconductors or technology continues to advance, this likely the naming conventions will adapt to reflect new breakouts and characteristics of the IC produced. Thank you for watching my video.